Hello, I'm John Huber, Applications Engineer with Apogee Instruments, and in this video we will be going over some of the more frequently asked questions regarding the operation and calibration of our SO100 and 200 series oxygen sensors. Now these sensors are unique among Apogee Instruments' product line in that they are user calibrated. And so one of the more frequently asked questions we get are, what are the best practices for calibrating and applying the readings from these sensors? So to calibrate it, you'll first want to set it up in an open air environment with a similar temperature, pressure, and humidity level as the sampling environment that you will be operating the sensor in. Once you've got it set up in this environment, you will want to let the sensor's millivolt readings stabilize, and then once they have, you will want to write down or record this millivolt reading as your calibration millivolt reading. Once you have this calibration millivolt reading, you will want to use it in the formulas listed in the SO100 and 200 manuals in order to obtain your calibration multiplier and calibration offset. Once you have this calibration multiplier and offset, you can use it to convert the sensor's millivolt signal into a measure of relative oxygen concentration. Now, the manual can be found on our website by going to the home page, scrolling down to the support heading, clicking Technical Support, then selecting the oxygen sensors, and clicking the link Product Manuals found below. In addition to the product manual, we have developed a calculator spreadsheet that will be posted under the Helpful Articles and Links section that will walk you through and run these calculations for you. So to use this spreadsheet, you'll want to follow these steps. First, enter your sensor model. In this case, we'll pick the SO110. Next, you want to enter your calibration millivolt reading that you recorded. In this case, we'll pick 45. And you can see, once I enter my calibration millivolt reading, the spreadsheet now gives me my calibration multiplier and calibration offset that I can use to convert my sensor's millivolt readings into a measure of relative oxygen concentration. An additional thing that this spreadsheet does is it allows you to correct for changes in environmental conditions. Now this is important because the oxygen sensor measures or outputs a millivolt signal based on absolute oxygen concentrations, which we convert into relative oxygen concentrations. The reason we don't just use absolute concentrations is because many environmental factors affect them. For example, if you're at sea level, the relative oxygen concentration in open air is going to be roughly 20.95%. On top of Mount Everest, it's also going to be 20.95%, but the absolute concentration of oxygen between these two environments will be very different. So, keeping that in mind, when you're using an oxygen sensor that's been calibrated in one environment, and you take it to a very different environment, you will need to make sure to correct its readings for changes in temperature, pressure, and humidity. And if you would like more information on why this happens and how these corrections are applied and how we came by these equations to apply these corrections, that information can be found in the SO100 and 200 product manual. But in this case, let's go ahead and show you how to enter your information into this spreadsheet and apply the corrections. So first, you're going to want to enter the environmental conditions for your calibration environment, starting with temperature. So let's select our units for temperature as Celsius, and then let's enter a value of 25 degrees. Now let's say the humidity level in your calibration environment was 10%. So we'll go ahead and punch that in. Next, you'll want to enter either the elevation of your calibration environment in order to estimate the barometric pressure of that environment or enter barometric pressure directly. We'll enter the barometric pressure value by clicking the button on the left here saying Use Calibration Pressure, and we will enter the barometric pressure in kPa of the calibration environment as, let's say, 89.5. Now that we have our calibration environment conditions entered, we can move on to our sample information. First, we'll want to start by entering the sample millivolt value, and let's go ahead and make up a value of 44 for this example. Now you can see the spreadsheet has already produced an uncorrected oxygen reading based on the information we gave it for the calibration readings and the sample millivolt reading that we just entered. Since that millivolt reading for the sample is a little bit lower, the oxygen reading reported by this spreadsheet is also lower at 20.4%. But it's important to remember this has not been corrected. So if your environment that you're sampling in is different from your calibration environment, the actual relative oxygen concentration will be different. So let's go ahead and apply those corrections. First, we'll need to enter our sample environment conditions, starting with temperature once again. Let's go ahead and enter it in Fahrenheit this time. And let's say that our sample environment was 75 degrees. Next, let's enter our humidity for our sample environment. And let's say that's about 50%. Next, we want to enter either the elevation or barometric pressure once again. This time, we'll use elevation to estimate barometric pressure. So we'll select our units as meters. And then let's say it was an elevation of 1,500 meters. And now, to apply corrections based on the information we have entered into this sheet, simply click the check boxes. So let's correct for humidity, let's correct for pressure, and let's correct for temperature. So now, you can see, based on the difference in environmental conditions between the calibration environment and the sample environment, the oxygen reading for our sample environment is 21.9%. Now once again, this is because the temperature, pressure, and humidity have changed between the calibration environment and the sample environment. Once again, that's why it's so important to calibrate your oxygen sensor in an environment similar to its sampling environment to minimize the need for these corrections. However, if that's not an option, you can use these corrections to correct your oxygen sensor's readings. And once again, both the oxygen sensor manual and this spreadsheet can be found in our support page for the oxygen sensor, and also cover the subjects that are covered in this video in very great detail. That being said, if you have any questions or if you have any issues that you would like to discuss with us or bring to our attention, you can reach us at our email address at techsupport@apogeeinstruments.com, or you can give us a call at 435-245-8012, or you can also leave a comment below. And if you would like to see more content from Apogee Instruments, feel free to click that subscribe button. Thank you for watching.